This week's lesson is about sum of interior angles. So we're going to look at how regular polygons can be broken up into triangular regions to determine the interior angles of each of them. So let's start with the triangle. I know in an equilateral triangle, all of the interior angles add up to 180 degrees. And then let's move on to a quadrilateral. So the regular quadrilateral is a square, and I can divide the square up into two triangular regions. So if I could make the square into two triangles, I know that each one of these triangular regions has to be 180 degrees. So if I add 180 plus 180, that would give me a total of 360 degrees. Okay, which we also know that if I added up the four right angles of a square, I would get 360 degrees. Now let's go on to a pentagon. Okay, pretend this is regular. I did just have to freehand it, so bear with my drawings of my shapes. If I start with one vertex, I could cut this into three triangular regions, which means I would have 180 degrees 3 times. So 180 times 3 would be 540 degrees. And then let's go on to the hexagon. So same thing, I could break it up from one vertex into 4 different triangular regions. So I would have 180, 180, 180, 180. So if I did 180 times 4, I would get 720 degrees. So as you can tell, as I go up and increase my sides of each polygon each time, I'm also increasing the triangular region by 1. I can add another triangular region each time I increase the side of a polygon. So let's see if we can come up with a pattern and figure out a rule to find the sum of the interior angles of a polygon. So let's take a look at this table based off of our findings from the previous page. So a triangle has 3 sides and makes up one triangular region. And we know that the sum of the interior angles of a triangle is 180. Now let's look at the quadrilateral. The quadrilateral has 4 sides, and if I were to take it and break it up into triangular regions, I could get 2 triangular regions out of it. So 2 times 180 would be 360 degrees. Now a pentagon has 5 sides, and I could break a pentagon into 3 different triangular regions, and so 3 times 180 would be 540 degrees. A hexagon has 6 sides, and I could break a hexagon up into 4 different triangular regions, and 4 times 180 is 720 degrees. So as you can tell, there should be a pattern forming. Let's start with the number of sides compared to the triangle regions. So with the triangle, I have 3 sides and 1 triangular region. And then as my sides increase, the triangle regions also increase as well. But you could tell that the triangle regions is always 2 less than the number of sides. So if I wanted to figure out how many triangular regions would be in a polygon with n number of sides, I would just subtract 2 from that number. Then, to find the sum of the interior angles, I multiply the number of triangular regions by 180. So for example, a hexagon, which has 1, 2, 3, 4 triangular regions, I would multiply that by 180 and get 720 degrees. So to find the sum of interior angles of any polygon, I would just multiply my triangular regions, which is represented by n minus 2, times 180. So from this pattern, we can come up with the formula to find the sum of any interior angle. Let me go ahead and write it down here, which would be, if I just went ahead and distributed out and multiplied each one of these terms by 180, I would end up with 180 n minus 360. So this is the formula to find the sum of the interior angles of any polygon. Alright, so let's look at some IXL examples using this formula. So for this question, we need to figure out how many triangles are formed by drawing all of the diagonals from a single vertex. So pick any random vertex of this polygon. I'm just going to start over here. And we're going to determine how many triangular regions can we form by drawing the diagonals from the single vertex. So just like the examples we did before in our notes, I know that I can form 1, 2, 3 triangular regions. So I would just submit 3 and go on to the next question. This question wants me to find the sum of the interior angles of this polygon. So we now know that the formula for the sum of the interior angles of a polygon is 180n minus 360. So n is the number of sides of the polygon. So in this case, I could count that this is a 1, 2, 3, 4, 5, 6-sided polygon, a hexagon. So I would plug in n equals 6 into this formula. So I would have 180 times 6 minus 360. Which would give me 720 degrees, which is what we found whenever we did the table at the very beginning of our notes. So I would submit 720 degrees. So for this problem, we don't want to find the sum of all the angles, we just want to know what one interior angle equals. So to do that, I'm going to take my total sum and then divide it by the number of interior angles. So for this polygon, I know my n equals 4 because it's a quadrilateral. There's 4 sides. So I'm going to plug it into this formula. 180 times 4 minus 360 would give me the sum, and then I would divide it by the number of angles, which happens to be the number of sides. So if I simplify and evaluate this, this would give me 360 divided by 4, which equals 90 degrees. So I know that each one of these angles would be 90 degrees. Last example, when we're throwing in some algebra, why not? I know you all love algebra mixed in with your geometry. So for this problem, we want to find the value of y. Well, in order to do that, I first need to figure out what the sum of all these interior angles would be. So let's use our sum formula, 180 times n minus 360. So let's figure out how many sides this polygon has. 1, 2, 3, 4, 5. So I know that my n equals 5 because this polygon has 5 sides. So I'm going to plug that into my formula. 180 times 5 minus 360 gives me 540 degrees. So that tells me all of these interior angles have to add up to 540 degrees. So let's go ahead and write an equation for that. I know 143 plus 133 plus 2y plus 138 plus y has to equal 540 degrees. So let's go ahead and simplify this. I'm going to add 143 plus 133 plus 138, which would give me 414. And then I can add 2y plus 1y to get 3y. And all of this still equals 540 degrees. So now I just need to solve for y. So I could subtract 414 and bring it to the other side of the equation, which would leave me with 3y equals 126. Then I need to solve for y and isolate y by itself. So I would divide each side by 3. 3 divided by 3 is just 1, which would leave me with 1y equals 42 degrees. So I would type in 42 and submit it. Alright, that's it for this lesson. Talk to you later. Bye.